Hello, this is Chad Houston. We're going to do a little flipped assignment on writing orbital notation for, or electron configuration shorthand notation. Okay, so this is something that people have been really struggling with. So let's imagine we have tin. So here's tin. Now tin has 50 electrons. Okay, so let's first of all, let's write it the long way first, and we'll see what happens. So if I were to write tin the long way, I have to account for 50 electrons. It has to follow the Aufbau diagram, right? So let's take a look here and see if I can get to the Aufbau diagram. So what I would do is it'd be 1s2, 2s2. I'm sorry, 1s2, then 2s2, 2p6, 3s2, 3p6, then 4s2, and then the 3d10s, and then 4p6, and then 5s2, and then 4d10, and then to get to 50, if we double check here, right, here's 10, it would end at 5p2. So I'm going to cheat. I'm going to click on 10. Hopefully, of course, now it's not. Oh, wait a minute. Let's cheat here. Let's click on 10. There's 10, and we'll go to the orbital side here. There's the orbital. Let's click on 10, and sure enough, it should end with, yes. So it ends with 5p2. So again, going up here, we said we fill the 1s2s, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 3d10. I'm sorry, 4d10. I apologize. And then 5s2. Now, we don't want to write all of that out. Okay, so here's what we're going to do. I'm going to snag this. Okay, and we're going to get 10 here. So let's take this here. I'm going to capture this, and here it is for 10. So instead, what I'm going to do is I'm going to say, for the shorthand notation, we always start at whatever element we're at, and we just go down in atomic numbers. And we go and we stop at the first noble gas. So the first noble gas previous to 10 would be krypton. So if we're doing krypton, notice we would have to have 36 electrons. So what I'm going to do then is I'm going to say, hey, let's do, if I have this krypton core written down, that accounts for all of this right here. Okay, so here's how we're going to do this shorthand notation, and this is the same for everyone. As it turns out, here is, okay, so here is 10. This is 10, okay, and if I stop at this right here are all the electrons that are krypton. So if I put the symbol Kr, that's what that means. So instead, I can just say, hey, here's my krypton core, which are these numbers, all of these electrons, and then what comes after krypton? Well, if we go back and check, right? If I look at krypton, here's krypton, right? I then go to my 5s2, 4d10, and then 5p2 right there. Okay, right here. So therefore, I would finish this and say, okay, for 10, it's 5s2, 4d10, and then 5p2. Now, the question is, what are the valence electrons? So the valence electrons, highest principal energy level and level, there's all my 5s, and it's really only the total s's and p's. Valence electrons would be 4 valence electrons. Okay. Okay, now let's do this for another one. Okay, let's get really crazy. Let's say we are now going to do, let's say that we're going to do barium. If we do barium, we look over here. I click on barium. I would have to write all this, okay, which is a ton. Instead, I'm going back. Okay, I'm going to hit my first noble gas, which is xenon. And if I do xenon, I have all these electrons, the first 54 electrons up to 5p6. So for barium, okay, what we'll do is we'll then say Again, I have 56 electrons. So barium, here's barium, 56 electrons, right? Okay, instead of having to write out the first 54 electrons, I'm going to stop at the previous noble gas. So again, there's barium. Here's the first noble gas, xenon. These are up to 5p6, all of those electrons. Okay, so now I'm going to say xenon core, which is all from 1s2 all the way up to 5p6. 54 electrons. That's the first 54 electrons. Now, where are we at? We're at 56, right? So let's take a look. Okay, so if it goes to 5p6, 6s2, that's where barium's going to end. So for this one, I would say 6s2. That's it for barium. It only has 2 valence electrons. And if I were to do the electron dot for barium, 1, 2. If I do the electron dot for tin, it would be 1, 2, 3, 4. And that's how you use the shorthand notation.